This lesson is on solving compound inequalities, section 6.4 in your textbook. The essential question is, what are the two types of compound inequalities, and how are they the same and how are they different? Compound inequalities are either combined by the word and, or they are combined by the word or. We will explore these two different kinds of compound inequalities. Let's start with the graphs of and type of inequalities. We're going to graph a few inequalities leading to the graph of an and type of inequality. First, graph the inequality x is greater than -2. We will use an open circle at -2 and draw our arrow to the right. The next graph, x is less than or equal to 1. We will use a closed circle at 1 and draw our arrow to the left. Now we want to look at the intersection or overlap of the two graphs. Let's graph the compound inequality x is greater than -2 and x is less than or equal to 1. We use an open circle at -2 and a closed circle at 1. The section that is the same in both graphs above is in between those two circles. Note, an inequality with and is the intersection of the graphs. Most of the ones we deal with in this class will be between the circles, but keep in mind that is not always the case. Now let's look at the or case. First, graph x is greater than or equal to 0. We use a closed circle at 0 and draw our arrow to the right. The next graph, x is less than -1. So we use an open circle at -1 and draw our arrow to the left. Let's combine the two inequalities to make a compound inequality with or. X is less than -1 or x is greater than or equal to 0. To graph an or inequality, you combine the graphs of each of the individual inequalities. Use an open circle at -1 with an arrow to the left and a closed circle at 0 with an arrow to the right. Notice the two arrows are going in opposite directions. Note an inequality with or is the union of the graphs, both graphs combined. Most of the graphs we are going to have with or inequalities will have the arrows going in opposite directions, but keep in mind that is not always the case. Let's look at translating words into mathematical inequality expressions. The first is to translate all real numbers that are greater than or equal to -4 and less than 4. The phrase all real numbers represents the x variable. The two phrases are greater than or equal to and less than represent the inequalities. Since we are using the word and between the two inequality phrases, we want to write a compound and inequality. So the x variable goes in the middle. You only do this with an and compound inequality. The small number goes on the left side of the variable. So -4 goes on the left. And the large number goes on the right side of the variable. +4 goes on the right. The inequalities should always point to the left. So x is greater than or equal to negative 4, and x is less than 4. Double check to make sure the inequality is correct, that x is greater than or equal to negative 4, and x is less than 4. So this inequality is correct. Now we graph it. Use a closed circle at negative 4, an open circle at 4, and shade in between the two circles. Note if the inequality is not written in the correct standard notation, small number on the left, large number on the right, and both inequality symbols pointed to the left, it will be marked wrong. The next example is an example of an OR expression. For this one, you write as two separate inequalities with an OR in the middle. Remember the phrase, all real numbers, represents the x variable. So we have x is less than negative 1, or x is greater than 2. X less than negative 1, or x greater than 2. Now we're going to graph the inequality. Open circle on negative 1, arrow to the left. Open circle on 2, arrow to the right. Here is a slide of practice if you would like to check your understanding. Work on these two practice problems, then restart the video to check your work. Pause now. Here's the answer slide. Pause the video if you need time to check, then restart for the remainder of the lesson. Pause now. Now let's solve inequalities. If we only look at the right half, what would our first step be? Subtract 3 from both sides. Now, let's look at the left half. What would our first step be? Subtract 3 from both sides. With a compound inequality, we just subtract 3 from all three parts at the same time. One minus 3, negative 2, less than negative 2x less than 16. Next, we divide all parts by negative 2 to isolate the variable x in the middle. So divide all parts by negative 2. Now remember, what happens when we divide by a negative number? The inequality symbols are going to switch direction. Now we have to rewrite our inequality so that it is in the proper format with the small number on the left, the large number on the right, and inequalities are both pointing to the left. So negative 8 on the left, arrow pointing at the negative 8, x in the middle, arrow pointing at the x to the left, 1 on the right. That is our solution. Now we will graph. Open circle at negative 8, open circle at 1, and shade in the middle. The next example is of an OR compound inequality. Solve each inequality individually, but remember to bring down the OR in the middle. Then graph the inequality. So the inequality 3x minus 2 less than or equal to negative 11. Add 2 to both sides. Three x less than or equal to -9. Divide by 3 on both sides. X less than or equal to -3. Or, you must remember to bring the or straight down. Now we're going to solve 2x plus 8 greater than 16. Minus 8 from both sides. 2x greater than 8. Divide by 2 on both sides. X greater than 4. So our solution is x less than or equal to -3 or x greater than 4. Use a closed circle at -3, arrow to the left, open circle at 4, arrow to the right. Here is a practice slide if you would like to check your understanding, then restart to check your answers. Pause now. Here are the answers. If needed, pause now and check your work and restart when ready. Pause now. In class, we'll look at some more practice work of what you learned in this video. See you in class.